Hydraulic retention time. So hydraulic retention time problems are not that bad. We've got hydraulic retention time and velocity. You said you wanted to work on both of those. And they have sort of similar looking formulas. So the velocity formula, this is slightly more complicated when we start looking at the units, but velocity is equal to the flow per area. So this is the formula that we're going to use for this one. Velocity can also be distance per time. So there's actually two formulas, and I think people sometimes find it a little confusing in the front of the test book because it's written more or less just like this. And they miss the fact that there's a little or in the middle of it, and so if you write that whole thing down, it looks kind of messy. You're not really sure what to do with those things. Velocity, at least in our business, is normally expressed as feet per second. And we are normally going to be finding area in square feet. That's sort of our go-to. So if we want all of the units to work out here, the flow has to be in cubic feet per second. So if I write it like this, it'll be a little clearer. So you see what happens here is that these 2 feet that are down here on the bottom, these two are going to cancel out 2 of the ones on top, and it's going to leave us with just feet per second, which is then going to match the other side here, feet per second. So helpfully, in the front of the test book, they tell you what units all of the velocity things have to be in. Okay, so, and then if it's just distance per time, of course that's just feet per second. So if you think about miles per hour, that would be an example of a velocity. So there's a couple of good problems that go with that. On the other side of things, we've got the hydraulic retention time formula, and time is equal to the volume divided by the flow. Okay, time is volume divided by flow. So let's talk about what these two things actually mean. Velocity, if I had a pipe like this, and I've got water flowing through the pipe, kind of heading this way, what we're interested in is sort of this cross-sectional area. Okay, so that's the amount, or the cross-sectional area that the flow is moving past or through. Same thing is true for a clarifier. We talk about surface overflow rate. And surface overflow rate is an upward velocity in the clarifier. So we've got water, kind of coming in, and it's flowing up and out of the clarifier like this. That's also a velocity. So if you look at the formula for surface overflow rate, it is gallons per day per square foot, which is just another way of writing velocity, because we've got, just like we had up here on the top, we have a flow. Oh, sorry, that should be square feet down there on the bottom. Flow per square feet. And down here on the bottom we have an area. So velocity, surface overflow rate, basically the same thing. Okay, but we're always interested in moving past or through a point. Now things can get a little confusing when they give us dimensions for an open channel, for example. Because if you just read it in the problem and they said that this thing was 2 feet wide and 2 feet deep and 10 feet long, you would be inclined to go get the dimensions for length and width, but that's this triangle, or this rectangle here. Oh, it's early. It's not a triangle. Rectangle. But that's not where the water is moving through or past. The water is moving through or past this rectangle. So we don't want the length and the width. We actually, in this case, want the width and the depth, which becomes the length and width of the new rectangle. Okay?
Okay.
Now for hydraulic retention time can actually mean a couple of different things. If I have a tank and I'm filling the tank, then the hydraulic retention time is essentially how long it takes for the tank to fill. If I have a tank and I'm pulling water out of the tank and the level's going down and no new water is coming into the tank, then the hydraulic retention time is going to be how long does it take to empty the tank. If water is coming in and going out at the same time, then the hydraulic retention time becomes the amount of time that your average little bit of water comes in, kind of circulates around, and then goes out of the tank. So it's your average amount of time. Now, all tanks have some level of short circuiting associated with them. They're not completely mixed most of the time. And so some of the water, if you drew a little bell curve, some of the water is actually going to short circuit and come out very quickly, and some of it's going to come out a little bit slower, but the average amount of time, so that mean time that's right in the center of the bell curve, that's what we're talking about when we say hydraulic retention time.